The logic of relatives. When in 1866, gentlemen, I had clearly ascertained that the three types of reasoning were induction, deduction, and retroduction. It seemed to me that I had come into possession of a pretty well-rounded system of formal logic. I had, it is true, a decided suspicion that there might be a logic of relations, but still I thought that the system I had already obtained ought to enable me to take the Kantian step of transferring the conceptions of logic to metaphysics. 1. My formal logic was marked by triads in all its principal parts. There are three types of inference: induction, deduction, and retroduction, each having three propositions and three terms. There are three types of logical forms: the term, the proposition, and the inference. Logic is itself a study of signs. Now a sign is a thing which represents a second thing to a third thing, the interpreting thought. There are three ways in which signs can be studied: first, as to the general conditions of their having any meaning, which is the grammatica speculative of Duns Scotus; secondly, as to the conditions of their truth, which is logic; and thirdly, as to the conditions of their transferring their meaning to other signs. The sign, in general, is the third member of a triad: first, a thing as thing; second, a thing as reacting with another thing; and third, a thing as representing another to a third. Upon a careful analysis, I found that all these triads embody the same three conceptions, which I call after Kant, my categories. I first named them quality, relation, and representation. I cannot tell you with what earnest and long continued toil I have repeatedly endeavored to convince myself that my notion that these three ideas are all fundamental importance in philosophy was a mere deformity of my individual mind. It is impossible. The truth of the principle has ever reappeared clearer and clearer. In using the word relation, I was not aware that there are relations which cannot be analyzed into relations between pairs of objects. Had I been aware of it, I should have preferred the word reaction. It was also perhaps injudicious to stretch the meaning of the word representation so far beyond all recognition as I did. 2. However, the words quality, reaction, representation might well enough serve to name the conceptions. The names are of little consequence. The point is to apprehend the conceptions. And in order to avoid all false associations, I think it far the best plan to form entirely new scientific names for them. I therefore prefer to designate them as firstness, secondness, and thirdness. I will endeavor to convey to you some idea of these conceptions. They are ideas so excessively general, so much more general than ordinary philosophical terms, that when you first come to them they must seem to you vague. Firstness may be defined as follows: it is the mode in which anything would be for itself, irrespective of anything else, so that it would not make any difference though nothing else existed, or ever had existed, or could exist. Now this mode of being can only be apprehended as a mode of feeling. For there is no other mode of being which we can conceive as having no relation to the possibility of anything else. In the second place, the first must be without parts. For a part of an object is something other than the object itself. Remembering these points, you will perceive that any color, say magenta, has and is a positive mode of feeling, irrespective of every other. Because firstness is all that it is, for itself, irrespective of anything else, when viewed from without, and therefore no longer in the original fullness of firstness. The firstnesses are all the different possible sense qualities, embracing endless varieties of which all we can feel are but minute fragments. Each of these is just as simple as any other. It is impossible for a sense quality to be otherwise than absolutely simple. It is only complex to the eye of comparison, not in itself. A secondness may be defined as a modification of the being of one subject, which modification is ipso facto a mode of being of quite a distinct subject, or, more accurately, secondness is that in each of two absolutely severed and remote subjects which pairs it with the other, not for my mind nor for, or by, any mediating subject or circumstance whatsoever, but in those two subjects alone, so that it would be just the same if nothing else existed, or ever had existed, or could exist. You see that this secondness in each subject must be secondary to the inward firstness of that subject and does not supersede that firstness in the least. For were it to do so, the two subjects would, in so far, become one. Now it is precisely their two-ness all the time that is most essential to their secondness. But though the secondness is secondary to the firstness, it constitutes no limitation upon the firstness. The two subjects are in no degree one, nor does the secondness belong to them taken together. There are two secondnesses, one for each subject, but these are only aspects of one pairedness which belongs to one subject in one way and to the other in another way. But this pairedness is nothing different from the secondness. It is not mediated or brought about, and consequently it is not of a comprehensible nature, but is absolutely blind. The aspect of it present to each subject has no possible rationale. In their essence, the two subjects are not paired, for in its essence anything is what it is, while its secondness is that of it which is another. The secondness, therefore, is an accidental circumstance. It is that a blind reaction takes place between the two subjects. It is that which we experience when our will meets with resistance, or when something obtrudes itself upon sense. Imagine a magenta color to feel itself and nothing else. Now while it slumbers in its magentaness, let it suddenly be metamorphosed into pea green. Its experience at the moment of transformation will be secondness. The idea of thirdness is more readily understood. It is a modification of the being of one subject which is a mode of a second so far as it is a modification of a third. It might be called an inherent reason. The dormitive power of opium by virtue of which the patient sleeps is more than a mere word. It denotes, however indistinctly, some reason or regularity by virtue of which opium acts so. Every law, or general rule, expresses a thirdness, because it induces one fact to cause another. Now such a proposition as, Enoch is a man, expresses a firstness. There is no reason for it, such is Enoch's nature, that is all. On the other hand, the result that Enoch dies like other men, as result or effect, expresses a secondness. The necessity of the conclusion is just the brute force of this secondness. In deduction, then, firstness by the operation of thirdness brings forth secondness. Next consider induction. The people born in the last census year may be considered as a sample of Americans. That these objects should be Americans has no reason except that that was the condition of my taking them into consideration. There is firstness. Now the census tells me that about half those people were males. And that this was a necessary result is almost guaranteed by the number of persons included in the sample. There, then, I assume to be secondness. Hence we infer the reason to be that there is some virtue, or occult regularity, operating to make one half of all American births male. There is thirdness. Thus, firstness and secondness following have risen to thirdness. There are my three categories. I do not ask you to think highly of them. It would be marvelous if young students in philosophy should be able to distinguish these from a flotsam and jetsam of the sea of thought that is common enough. Besides, I do not ask to have them distinguished. All thought both correct and incorrect is so penetrated with this triad, that there is nothing novel about it, and no merit in having extracted it. I do not at present make any definite assertion about these conceptions. I only say, here are three ideas, lying upon the beach of the mysterious ocean. They are worth taking home, and polishing up, and seeing what they are good for. I will only say this, there is a class of minds whom I know more intimately probably than many of you do, in whose thought, if it can be called thought, firstness has a relative predominance. It is not that they are particularly given to hypothetic inference, though it is true that they are so given, but that all their conceptions are relatively detached and sensuous. Then there are the minds whom we commonly meet in the world, who cannot at all conceive that there is anything more to be desired than power. They care very little for inductions, as such. They are nominalists. They care for the things with which they react. They do reason, so far as they see any use for it, and they know it is useful to read. But when it comes to a passage in which the reasoning employs the letters A, B, C, they skip that. Now the letters A, B, C are pronouns indispensable to thinking about thirdness, so that the mind who is repelled by that sort of thought is simply a mind in which the element of thirdness is feeble. Finally, there is the geometrical mind, who is quite willing that others should snatch the power and the glory so long as he can be obedient to that great world vitality which is bringing out a cosmos of ideas, which is the end toward which all the forces and all the feelings in the world are tending. These are the minds to whom I offer my three categories as containing something valuable for their purpose. These categories manifest themselves in every department of thought, but the advantage of studying them in formal logic is, that there we have a subject which is very simple and perfectly free from all doubt about its premises, and yet is not like pure mathematics confined entirely to purely hypothetical premises. It is the most abstract and simple of all the positive sciences, and the correct theory of it is quite indispensable to any true metaphysics. Having in 1867 made out the three categories, three various facts proved to me beyond a doubt that my scheme of formal logic was still incomplete. For instance, I found it quite impossible to represent in syllogism any course of reasoning in geometry or even any reasoning in algebra except in Boole's logical algebra. I had already ascertained that Boole's algebra was inadequate to the representation of ordinary syllogisms of the third figure, and though I had invented a slight enlargement of it to remedy this defect, yet it was of a makeshift character, plainly foreshadowing something yet unseen more organically connected with the part of the algebra discovered by Boole. In other directions, Boole's system strongly suggested its own imperfection. Pondering over these things, my notebook shows that I soon came out upon the logic of relatives, and had so complemented the Boolean algebra as to give it power to deal with algebraic relations. I learned from the great memoir of Professor de Morgan, dated 1860, which he now sent me, that the same ground had already been considerably explored by him, though by a different route, starting from his own line of logical thought as expounded in his work Formal Logic. It is now time to explain to you this logic of relatives. For I will first give a chronology of the most important papers. I shall not mention any that are not quite fundamental. Relation was recognized as a part of the subject matter of logic by Aristotle and all ancient and medieval logicians. There is a tractate De Relativis probably dating from the 11th century appended to the Sumuli of Petrus Hispanus. Arkham and Paulus Venetus treat of it in their extended treatises on logic. Leslie Ellis made a single obvious remark on the application of algebra to it which Professor Halstead thinks makes him the author of the logic of relatives. The remark is really fundamental. Yet it was exceedingly obvious, and was not followed out. Next came De Morgan's memoir. Then in 1870, came my first mode of extending Boole's logical algebra to relatives. In 1883 I gave what I call the algebra of Didactic relatives, which Schroeder has fallen in love with. In the same volume O. H. Mitchell, in one of the most suggestive chapters that the whole history of logic can show, gave a method of treating a logical universe of several dimensions, which I soon after showed amounted to a new algebraic method of treating relatives generally. One call it the general algebra of logic. I think this the best of the algebraic methods. In 1890, Mr. B. Kemp published an extended memoir on mathematical form which is really an important contribution to the logic of relatives. Schroeder's third volume treats of the subject at great length, but in the interest of algebra rather than in that of logic. Finally, about 2 years ago, one developed two intimately connected graphical methods which I call interpretative and existential graphs. I shall here treat the subject by means of existential graphs, which is the easiest method for the unmathematical. Still, I shall not attempt to set this forth at all. I shall not even trouble you with the statement of its 9 fundamental rules, far less with the score of others with which it is necessary to familiarize oneself in order to practice the method. But I shall describe in a confused, illogical fashion every essential feature of the system. Let us pretend to assert anything we write down on the blackboard. As long as the board remains blank, whatever we may opine, we assert nothing. If we write down you are a good girl, we assert that. If we write you are a good girl, you obey mamma, we assert both. This is therefore a copulative proposition. When we wish to assert something about a proposition without asserting the proposition itself, we will enclose it in a lightly drawn oval, which is supposed to fence it off from the field of assertions. Thus carrot you are a good guy, carrot is false. This last assertion that a proposition is false is a logical statement about it, and therefore in a logical system deserves special treatment. It is also by far the commonest thing we have occasion to say of propositions without asserting them. For those reasons, let it be understood that if a proposition is merely fenced off from the held of assertion without any assertion being explicitly made concerning it, this shall be an elliptical way of saying that it is false. Accordingly, you are a good girl, you obey mamma is the copulative proposition. You are not a good girl, but you obey mamma. The denial of a copulative proposition is a disjunctive proposition. Thus you are a good girl, you obey mamma, which denies that you are both a good girl and obey mamma, asserts that you are either not a good girl or you do not obey mamma. So are a good girl, K you obey mamma, J asserts that you are either a good girl or do not obey mamma, that is, if you obey mamma you are a good girl. This is a conditional proposition. It is a species of disjunctive proposition. Copulative and disjunctive propositions are the two kinds of hypothetical propositions, and are generally recognized as such. Kant had a purpose in endeavoring to wrench this plain division into another form, or thought he had, and Kantian logicians have been too feeble-minded to dispute their master. Now there remains only one little bit of a feature to complete the description of the system. But this little feature is everything. Namely, we will use a heavy line to assert the identity of its extremities. Thus is a good girl obeys mamma shall mean there exists something that is a good girl and is identical with something that obeys mamma. That is some existing good girl obeys mamma. Or we can better express this, thus is a good girl, that is, some existing good girl obeys the mamma of her. Now as long as there is but one such line of identity, whether it branches or not, the forms of inference are just the same as if there were no such line. But the moment there are two or more such lines, new forms of inference, unknown to ordinary logic, become possible. For example, let us write that means, there is something which whoever loves obeys. For it says, there is something of which it is not true that somebody loves it and yet does not obey it. From this we can infer, by a very simple principle which means whoever loves everything obeys something. For it denies that there is something of which it is not true that there is something that it does not love and yet of which it is not true that there is something that it obeys. You will find it impossible to express this simple inference syllogistically. There is all the mathematics with which I intend to burden your poor heads. I hope you will not suffer from the effects of it. I will try to give you a rest now, by passing to something easier. But mind, you certainly miss very important revelations concerning the question of nominalism and realism by being shut out from that great world of logic of which I have just given you one momentary glimpse as I whisk you by it in our railway journey through the forms of reasoning. Any part of a graph which only needs to have lines of identity attached to it to become a complete graph, signifying an assertion, I call a verb. The places at which lines of identity can be attached to the verb I call its blank subjects. I distinguish verbs according to the numbers of their subject blanks, as medods, monads, dids, triads, etc. A medod, or impersonal verb, is a complete assertion, like it rains you are a good girl. A monad, or neuter verb, needs only one subject to make it a complete assertion, as obeys mama you obey a did, or simple active verb, needs just two subjects to complete the assertion as, obeys, or, is identical with a triad, needs just three subjects as obeys both t and now I call your attention to a remarkable theorem. Every polyad higher than a triad can be analyzed into triads, though not every triad can be analyzed into dids. Thus, the tetrad, for the price, can be analyzed into these triads. From this theorem we see that our list of categories is complete. 5 I do not say there is no conception of fourthness. We know that the tetrad was most sacred with the Pythagoreans. Of that, however, I believe I have the secret. If so, it argues nothing. But the fourthness in melody for example is indisputable. It contains however no peculiar intellectual element not found in firstness, secondness, and thirdness. Let me say again that the connection of my categories with the numbers 1, 2, 3, although it affords a convenient designation of them, is a very trivial circumstance. In the system of graphs may be remarked three kinds of signs of very different natures. First, there are the verbs, of endless variety. Among these is the line signifying identity. But, second, the ends of the lines of identity, and every verb ought to be conceived as having such loose ends, are signs of a totally different kind. They are demonstrative pronouns, indicating existing objects, not necessarily material things, for they may be events, or even qualities, but still objects, merely designated as this or that. In the third place the writing of verbs side by side, and the ovals enclosing graphs not asserted but subjects of assertion which last is continually used in mathematics and makes one of the great difficulties of mathematics, constitute a third, entirely different kind of sign. Signs of the first kind represent objects in their firstness, and give the significations of the terms. Signs of the second kind represent objects as existing, and therefore as reacting, and also in their reactions. They contribute the assertive character to the graph. Signs of the third kind represent objects as representative, that is in their thirdness, and upon them turn all the inferential processes. In point of fact, it was considerations about the categories which taught me how to construct the system of graphs. Although I am debarred from showing anything in detail about the logic of relatives, yet this I may remark, that where ordinary logic considers only a single, special kind of relation, that of similarity, a relation, too, of a particularly featureless and insignificant kind, the logic of relatives imagines a relation in general to be placed. Consequently, in place of the class, which is composed of a number of individual objects or facts brought together in ordinary logic by means of their relation of similarity, the logic of relatives considers the system, which is composed of objects brought together by any kind of relations whatsoever. For instance, ordinary logic recognizes such reasoning as this: A does not possess any shade of grey, B does possess a shade of grey, A is not B, but the logic of relatives sees that the quality grey here plays no part that any object might not play. Nor does the relation of possessing as a character differ in its logical powers from any other dadic relation. It therefore looks upon that inference as but a special case of one like the following: A loves everybody of the name of grey, B has a servant of the name of grey, A loves a servant of B, but there are inferences in the logic of relatives which have not so much resemblance to anything in ordinary logic. Among the classes which ordinary logic recognizes, general classes are particularly important. One whose general classes are composed not of real objects, but of possibilities, and hence it is that the nominalist for whom, though he be so mild a nominalist as Hegel was, a mere possibility which is not realized is nothing but what they call an abstraction and little better, if at all, than a fiction. It will be instructive, therefore, to inquire what it is in the logic of relatives which takes the logical position occupied in ordinary logic by generality or in medieval language by the universal. Let us see, then, what it is that, in the logic of relatives, corresponds to generality in ordinary logic. From the point of view of secondness, which is the pertinent point of view, the most radical difference between systems is in their multitudes. For systems of the same multitude can be transformed into one another by mere change of thirdness, which is not true of systems of different multitude. A system of multitude 0 is no system, at all. That much must be granted to the nominalists. It is not even a quality, but only the abstract and germinal possibility which antecedes quality. It is at most being per se. A system of multitude unity is a mere first. A system of the multitude of 2 is like the system of truth and falsity in necessary logic. A system of the multitude of 3 is the lowest perfect system. The finite multitudes are all marked by this character that if there be a relation in which every individual in such a system stands to some other but in which no third stands to that other, then to every individual of the system some other individual stands in that relation. We next come to the multitude of all possible different finite multitudes, that is to the multitude of the whole numbers. A system of this multitude, which I call the denumeral multitude, is characterized by this, that though finite, yet its individuals have what I call generative relations. These are dadic relations of relate to correlate such that, taking any one of them, whatever character belongs to the correlate of that relation wherever it belongs to the relate, and which also belongs to a certain individual of the system, which may be called the origin of the relation, belongs to every individual of the system. For example, in the system of cardinal numbers from 0 up, the relation of being next lower in the order of magnitude is a generative relation. For every character which is such that if it belongs to the number next lower than any number also belongs to the number itself, and which also belongs to the number 0 belongs to every number of the system. The next multitude is that of all possible collections of different finite collections, of finite multitudes. This is the multitude of irrational quantities. I term it the first abnumeral multitude. The next multitude is that of all possible collections of finite multitudes. I call it the second abnumeral multitude. The next is the multitude of all possible collections of finite multitudes. There will be a denumeral series of such abnumeral multitudes. I prove that these are all different multitudes in the following way. In the first place, I say, that taking any such collection, which we may designate as the collection of A's, if each individual has an identity distinct from all other A's, then it is manifestly true that each collection of A's has an identity distinct from all other collections of A's, for it is rendered distinct by containing distinctly different individuals. But the individuals of a denumeral collection, such as all the whole numbers, have distinct identities. Hence, it follows that the same is true of all the abnumeral multitudes. But this does not prove that those multitudes are all different from one another. In order to prove that, I begin by defining, after Dr. Georg Cantor, what is meant by saying that one collection of distinct objects, say the Bs, is greater in multitude than another multitude of distinct objects, say the As. Namely, what is meant is that while it is possible that every A should have a distinct B assigned to it exclusively, and not to any other A, yet it is not possible that every B should have a distinct A assigned to it exclusively and not to any other B. Now then suppose the A's to form a collection of any abnumeral multitude, then all possible collections of different A's will form a collection of the next higher abnumeral multitude. It is evidently possible to assign to each A distinct collection of A's, for we may assign to each a collection of all the other A's. But I say that it is impossible to assign to every collection of A's a distinct A. For let there be any distribution of collections of A's which shall assign only one to each A, and I will designate a collection of A's which will not have been assigned to any A whatever. For the A's may be divided into two classes, the first containing every A which is assigned to a collection containing itself, the second containing every A to which is assigned a collection not containing itself. Now, I say that collection of A's which is composed of all the A's of the second class and none of the first has no A assigned to it. It has none of the first class assigned to it, for each A of that class is assigned to but one collection which contains it while this collection does not contain it. It has none of the second class assigned to it, for each A of this class is assigned only to one collection which does not contain it, while this collection does contain it. It is therefore absurd to suppose that any collection of distinct individuals, as all collections of abnumeral multitudes are, can have a multitude as great as that of the collection of possible collections of its individual members. But now let us consider a collection containing an individual for every individual of a collection of collections comprising a collection of every abnumeral multitude. That is, this collection shall consist of A finite multitudes together with all possible collections of those multitudes, together with all possible collections of those multitudes, together with all possible collections of those multitudes, and so on ad infinitum. This collection is evidently of a multitude as great as that of all possible collections of its members. But we have just seen that this cannot be true of any collection whose individuals are distinct from one another. We, therefore, find that we have now reached a multitude so vast that the individuals of such a collection melt into one another and lose their distinct identities. Such a collection is continuous. Consider a line which returns into itself, a ring. That line is a collection of points. For if a particle occupying at any one instant a single point moves until it returns to its first position, it describes such a line, which consists only of the points that particle occupied during that time. But no point in this line has any distinct identity absolutely discriminated from every other. For let a point upon that line be marked. Now this mark is a discontinuity, and therefore I grant you that this point is made by the marking distinctly different from all other points. Yet cut the line at that point, and where is that marked point now? It has become 2 points. And if those two ends were joined together so as to show the place, they would become one single point. But if the junction ceased to have any distinguishing character, that is any discontinuity, there would not be any distinct point there. If we could not distinguish the junction, it would not appear distinct. But the line is a mere conception. It is nothing but that which it can show, and therefore it follows that if there were no discontinuity there would be no distinct point there, that is, no point absolutely distinct in its being from all others. Again going back to the line with 2 ends, let the last point of one end burst away. Still there is a point at the end still, and if the isolated point were put back, they would be 1 point. The end of a line might burst into any discrete multitude of points whatever, and they would all have been 1 point before the explosion. Points might fly off, in multitude and order like all the really rational quantities from 0 to 1, and they might all have had that order of succession in the line and yet all have been at 1 point. Men will say this is self-contradictory. It is not so. If it be so, prove it. The apparatus of the logic of relatives is a perfect means of demonstrating anything to be self-contradictory that really is so, but that apparatus not only absolutely refuses to pronounce this self-contradictory but it demonstrates, on the contrary, that it is not so. Of course, I cannot carry you through that demonstration. But it is no matter of opinion. It is a matter of plain demonstration. Even although I should have fallen into some subtle fallacy about the series of abnumeral multitudes, which I must admit possible in the sense in which it is possible that a man might add up a column of 5 figures in all its 120 different orders and always get the same result, and yet that result might be wrong, yet one say, although all my conclusions about abnumerals were brought to ruin, what I now say about continuity would stand firm. Namely, a continuum is a collection of so vast a multitude that in the whole universe of possibility there is not room for them to retain their distinct identities, but they become welded into one another. Thus the continuum is all that is possible, in whatever dimension it be continuous. But the general or universal of ordinary logic also comprises whatever of a certain description is possible. And thus the continuum is that which the logic of relatives shows the true universal to be. I say the true universal, for no realist is so foolish as to maintain that universal is a fiction. Thus, the question of nominalism and realism has taken this shape, are any continua real? Now Kant, like the faithful nominalist, that Dr. Abbot 6 has shown him to be, says no. The continuity of time and space are merely subjective. There is nothing of the sort in the real thing in itself. We are therefore not quite to the end of the controversy yet, though I think very near it. 7 What is reality? Perhaps there isn't any such thing at all. As I have repeatedly insisted, it is but a retroduction, a working hypothesis which we try, our one desperate forlorn hope of knowing anything. Again it may be, and it would seem very bold to hope for anything better, that the hypothesis of reality though it answers pretty well, does not perfectly correspond to what is. But if there is any reality, then, so far as there is any reality, what that reality consists in is this, that there is in the being of things something which corresponds to the process of reasoning, that the world lives, and moves, and has its being, in, a, logic of events. We all think of nature as syllogising. Even the mechanical philosopher, who is as nominalistic as a scientific man can be, does that. The immutable mechanical law together with the laws of attraction and repulsion form the major premise, the instantaneous relative positions and velocities of all the particles whether it be at the end of the 6th day of creation, put back to an infinitely remote past if you like, though that does not lessen the miracle, or whether it be at any other instant of time is the minor premise, the resulting accelerations form the conclusion. That is the very way the mechanical philosopher conceives the universe to operate. I have not succeeded in persuading my contemporaries to believe that nature also makes inductions and retroductions. They seem to think that her mind is in the infantile stage of the Aristotelian and Stoic philosophers. I point out that evolution wherever it takes place is one vast succession of generalizations, by which matter is becoming subjected to ever higher and higher laws, and I point to the infinite variety of nature as testifying to her originality or power of retroduction. But so far, the old ideas are too ingrained. Very few accept my message. I will submit for your consideration the following metaphysical principle, which is of the nature of a retroduction. Whatever unanalyzable element sui generis seems to be in nature, although it be not really where it seems to be, yet must really be in nature somewhere, since nothing else could have produced even the false appearance of such an element sui generis. For example, I may be in a dream at this moment, and while I think I am talking and you are trying to listen, I may all the time be snugly tucked up in bed and sound asleep. Yes, that may be, but still the very semblance of my feeling a reaction against my will and against my senses suffices to prove that there really is, though not in this dream, yet somewhere, a reaction between the inward and outward worlds of my life. In the same way, the very fact that there seems to be thirdness in the world, even though it be not where it seems to be, proves that real thirdness there must somewhere be. If the continuity of our inward and outward sense be not real, still it proves that continuity there really be, for how else should sense have the power of creating it? Some people say that the sense of time is not in truth continuous, that we only imagine it to be so. If that be so, it strengthens my argument immensely. For how should the mind of every rustic and of every brute find it simpler to imagine time as continuous, in the very teeth of the appearances, to connect it with by far the most difficult of all the conceptions which philosophers have ever thought out, unless there were something in their real being which endowed such an idea with a simplicity which is certainly in the utmost contrast to its character in itself. But this something must be something in some sense like continuity. Now nothing can be like an element so peculiar except that very same element itself. Of all the hypotheses which metaphysicians have ever broached, there is none which quarrels with the facts at every turn, so hopelessly, as does their favorite theory that continuity is a fiction. The only thing that makes them persist in it is their notion that continuity is self-contradictory, and that the logic of relatives when you study it in detail will explode forever. I have refuted it before you, in showing you how a multitude carried to its greatest possibility necessarily becomes continuous. Detailed study will furnish fuller and more satisfying refutations. The extraordinary disposition of the human mind to think of everything under the difficult and almost incomprehensible form of a continuum can only be explained by supposing that each one of us is in his own real nature a continuum. I will not trouble you with any disquisition on the extreme form of realism which I myself entertain, that every true universal, every continuum, is a living and conscious being, but I will content myself with saying that the only things valuable, even here in this life, are the continuities. The zero collection is bare, abstract, germinal possibility. The continuum is concrete, developed possibility. The whole universe of true and real possibilities forms a continuum, upon which this universe of actual existence is, by virtue of the essential secondness of existence, a discontinuous mark, like a line figure drawn on the area of the blackboard. There is room in the world of possibility for any multitude of such universes of existence. Even in this transitory life, the only value of all the arbitrary arrangements which mark actuality, whether they were introduced once for all at the end of the sixth day of creation, or whether, as I believe, they spring out on every hand and all the time, as the act of creation goes on, their only value is to be shaped into a continuous delineation under the creative hand, and at any rate their only use for us is to hold us down to learning one lesson at a time, so that we may make the generalizations of intellect and the more important generalizations of sentiment which make the value of this world. Whether when we pass away, we shall be lost at once in the boundless universe of possibilities, or whether we shall only pass into a world of which this one is the superficies and which itself is discontinuity of higher dimensions, we must wait and see. Only if we make no rational working hypothesis about it we shall neglect the department of logical activity proper for both intellect and sentiment. Endeavors to effectuate continuity have been the great task of the 19th century. To bind together ideas, to bind together facts, to bind together knowledge, to bind together sentiment, to bind together the purposes of men, to bind together industry, to bind together great works, to bind together power, to bind together nations into great natural, living, and enduring systems was the business that lay before our great-grandfathers to commence and which we now see just about to pass into a second and more advanced stage of achievement. Such a work will not be aided by regarding continuity as an unreal figment, it cannot but be helped by regarding it as the really possible eternal order of things to which we are trying to make our arbitrariness conform. As to detached ideas, they are of value only so far as directly or indirectly, they can be made conducive to the development of systems of ideas. There is no such thing as an absolutely detached idea. It would be no idea at all. For an idea is itself a continuous system. But of ideas those are most suggestive which detached though they seem are in fact fragments broken from great systems. Generalization, the spilling out of continuous systems, in thought, in sentiment, indeed, is the true end of life. Every educated man who is thrown into business ought to pursue an avocation, a side study, although it may be well to choose one not too remote from the subject of his work. It must be suited to his personal taste and liking, but whatever it is, it ought, unless his reasoning power is decidedly feeble, to involve some acquaintance with modern mathematics, at least with modern age.